let me try and solve it. So how do I solve question number 1A? So I want to solve the probability that they break even after 6 tosses. So let's break even means both of them have lost and earned the same amount of money. Right? So let's look at 1A. Let's do 1A. So the way I think about it is that, so Netika, she can win 100 rupees with probability half on any given toss. It's a fair coin. So it's a fair coin. So first observation is that Netika can win 100 rupees on any given toss with probability half. And that's the first premise we make, because each person bets 100 rupees on and they have 600 rupees in hand. Right? So now to break even after 6 tosses, she must win 3 and she must lose 3. Right? That's what break even is. So that's a key observation you have to make. So to break even means what? Netika should lose 3 tosses, lose 3 and win 3 tosses in 6 tosses. Right? That's why that's exactly what she. Right? That means she has broken even. That means you have to have 3 successes or 3 failures, whichever you can, the same thing, in 6 tosses. So it's a binomial experiment. So the probability of this happening is, probability of break even is going to be what? So you have 6 tosses. So let's do 6 tosses. 6 tosses, and you choose 3 of them. So 6 choose 3 ways. In the 3 places you must win. So yes, half to the power 3. In the other 3 places you must lose. That is 6 minus 3. So this is like if you do this calculation, it is like, I think it is let's do the calculation. So it is 6 into 5 into 4 divided by 3 into 2 into 1. That's this part. Is 1 by 2 to the power 6 here. Okay, this is the 2 things together. So 6 and 6 cancel off, and these 2 things, like 3 into 6. 4 cancels off with 2 of them, so you get 4. So it is 5 by 16. That's the answer. And that's like 0.31. Very good. So is this part clear? Is for everybody who came? Anybody has any questions on this part in the Zoom? Sure. Very nice. So this part is clear, right? So this part is fairly simple. Then the second part is second question is a little tricky. So you have to be a little careful. So let's try and spend a few minutes understanding the question. So it says, what is the probability that Netika wins all the money in the 10th toss? So it's a very, you have to think a little bit. So 10th toss. So let's see. So Netika must win all the money on the 10th toss. So she must win 8 of them and lose 2 of them, right? If she has to win all the money, because that's the only way she can. That way she ends up getting 600 plus 800 minus 200, which is 1200. Right? So let's write that down. So first observation you have to make is the following in 1B. So if Netika has to win all the money in the 10th toss, if Netika has to win all the money, that means total money is what? 600 and 600 is 1200. Win all of the money on the 10th toss, then what happens? Then she must win what? She must win 8 and lose 2, right? Is that clear? Otherwise, she can't win all the money. She must win 8 and lose 2. This is important. Yeah. So this way, what will happen if this happens? She will end up with what? She will end up with. So she'll end up with what? Let's write the answer now. She'll end up with what? She'll end up with 600 for the wins, for all her money, plus 800 for the wins, and then she has lost 200. Right? So that will give her 1200. So is that clear? That's the first. That's the first observation. This is one observation. So observation number one. So let me write it in purple perhaps. Observation number one is this. Okay. The second observation you have to do is that she has to win the 10th toss. The 10th toss she must win. Otherwise, the game will not end at 10th. So she must also win the 10th toss. She must win the 10th toss. And that's what the problem demands, right? That Netika, the problem demands that what's the question? The probability that Netika wins all the money on the 10th toss. Right? So 10th toss she must win. That's when the game ends. Then she must also win toss number 9, because if she lost toss number 9 and wins toss number 10, and she had 1200 after the 8th toss itself. Right? So another observation is that she must win. Sorry, what's happened here? Great. I hope you can all still see the screen. Very good. So the other observation is that she must also win the 9th toss. Why is this true? Because if she lost 9 and 1 9th and 1/10th, which would imply at 8th toss itself she had 1200. But there was no gain in the 9th and 10th. Right? She's lost 9. So that can't happen, because you want the game to win on the 10th, enter the 10th toss. Very good. So this is the next observation. The third one you have to make is the following. That so once you know that she's won the 10th toss and the 9th toss, the last two are won by her, right? So then she must win also 6 of the first 8, because she's won the 9th and 10th. That's total 2 more, and she has to win 8. She has to win 8 of the and lose 2. She's already picked up 2 wins in the 9th and the 10th. So 9th and 10th are both wins. So the last one should be last option is she should win 6 out of the first 8. She must win 6 out of the first 8. This is observation. So how many ways are doing 6 out of the 8? This is 8 choose 6 ways. So this is 8 choose 6 ways. So this is 8 choose 6 ways of doing it, and that's 8 into 7 into that's 8 choose 2. Same as 8 choose 2. That's 8 into 7 by 2 into 1. That's 28 ways. Right? This is 28 ways. Very nice. So now this is there. There's one forbidden thing. She can't win the first 8 and lose the last 2. That's also not allowed, right? That's one thing. Because suppose she wins, let's say this is not allowed. Because she wins, 3 wins, then 4 wins, 5 wins, 6 wins, and then LL. This is not allowed. Okay, because if this happens also, not allowed. Why is this not allowed? Can someone tell on chat why it's not allowed? Right. So let's say she'll win it all at 6 toss. Very good. So that means if this happens, it's not allowed because she wins. That means this means she wins everything in the 6th toss itself. This is not allowed. So this combination also not allowed. That means out of 28, 27 are okay. So that means the rest 27 are okay. Very nice. And then you have 10 tosses, and then rest 27 ways are okay. Then all you have to do is the last observation is that each way has a probability of each specific record given by any of the 27 ways has probability equal to 1 over 2 to the 10. Because there are 10 tosses, each has probability half of winning or losing, so it's 1 over 2. So therefore the answer is, therefore the probability. So what did we ask? We asked the probability that Netika wins all the money in the 10th toss. So probability that Netika wins all the money in the 10th toss, is equal to exactly what we have. It's 27 ways, that is we have 27, into each way has probability 1 over 2 to the 10. So that's about, I think 27 by 2 to the 10 is 27 by 1024. And that's about, I think, 0.02637. Very good. Let me recap so you can sort of take notes on this question a little bit. Right. So that's the idea, right? So, okay, first of all, people on YouTube, if you want to join the Zoom link, this is the ID, and it's 818-9533-8568, and the password is 1234. So please join us on Zoom. You can chat with me on Zoom. It's no problem. I will not watch the YouTube chat, fortunately, on the Zoom. So I started solving this at 4:15 p.m. The question was the first one on assignment 3. This is assignment 3 questions. So the first question was that probability that Netika, they break even after 6 tosses. That means Netika should lose the first 3 and win the next 3. So the answer was that 6 choose 3, 1/2 to the power 3, and 1/2 to the power 6 minus 3. And that gave you 5 by 16. The second question was probability that Netika wins all the money on the 10th toss. So that was a little tricky to do. So you have to just work it out properly. So the first thing you have to do is Netika has to win all the money on the 10th toss. That means she must win 8 and lose 2. Otherwise, she can't make all the money because she need to get 600 plus 800 minus 200, which is 12. Because start off with 600, so she gains 800 and loses 200. She must also win the 10th toss. Otherwise, the game will win earlier. Very nice. Then she must win the 9th toss also, because if she lost the 9th, that means she would have lost at the 8th toss itself. She would have won all the 1200. So 9th and 10th she wins. That means you're left with 8 tosses to do rest of the 8 wins. So you already have 2 wins for the 9th and 10th. So 8 minus 2, 6. So you must win 6 out of that first 8 tosses. So that's 8 choose 6, that is 28 ways. But then you also know among this, one of the ways is not allowed. You can't, among the first 8, this is the first 8. This way is not allowed, because if you win the first 6, you have cleaned out the other guy. You have cleaned out the Gupta. So you can't do this because you want to play the game till the 10th toss. So this way is not allowed. Otherwise, every other way is allowed. There's no problem because you're a broken even or in one of the, if you have win-loss before it. So rest 27 are okay. That means and then last thing, notice that each specific record given by any of 27 ways has probability 1 over 2 to the 10. Means probability Netika wins all the money in 10th toss is 27 times 1 over 2 to the 10. That is 27 by 1024. That is 0.02637. Very good. If you have any questions, you can ask on chat. I will answer, and then I'll pose the next question to think about. So 1B was a little tricky. I don't know how many of you attempted 1B, but okay, let me try and solve this question. So now here, So here x denotes the sum of the dice and y denotes the value of the first die. So probability x equal to 7. So x is sum of the two dice, right? So first, let's go back to our probability ideas a little bit. So here, first we do is, so what is the sample space? I roll two dice, right? I roll two dice. So I can think of it as S as just all possible. I have 1, 1, 1, 2. There's one on the first, one on the first, second, or second, one on the first, two on the second, one on the first, three on the second, and so on and so forth. One on the first, six on the second. Very good. Similarly, here I can go all the way down and get 6 on the first, 1 on the second, 6 on the first, 2 on the second, all the way up to 6 and 6. So that is my sample space. Right? And x denotes the sum. Right? X denotes the sum. That means I have to understand in this question what is x equal to 7. So x is a function from s to the real line. So sum. So sum can go from what? Some of the dice can start at 2, 3, 4, and all the way up to 12. That's what the range of x is, right? This range of x is t. So we put this across a little bit further away. So t is equal to this. So x is from s to t, and t is equal to this because x is the sum of the. So let me see. So now this is how x looks like. X. So now what you do is when you have to calculate probability of x equal to 7, you have to identify what happens in S. Right? So what is the set? What is the set in S? So you want to calculate this question. What do you want to calculate? You have to understand how x equal to 7 looks in S. Okay? So for that, let me just do a little detour. So I'll explain a little bit more. So this is like someone asked a question on even the discussion forum. See, this is an equally likely outcome experiment because every outcome is equally likely. Right? Equally likely outcomes because I'm rolling two dice. Every outcome is equally likely. So what is the probability of any outcome? So any event A, probability of any single outcome. So it's equal likely outcome experiment. Let's call this the probability here is the question. So let me write this in black. So in this experiment, I know probability of any outcome K in S. Let's say any outcome K in S. So the tuple, let's say, let me call it as any I comma J in S, or let's say I comma J in S is just 1 by 36, right? For 1 less than equal to I less than equal to 6, and 1 less than equal to is less than equal to 6. So everybody is 1 over 36. Right? And then probability of any event A is going to be the sum over all I comma J in A times the probability of every outcome in A. But every outcome has the same probability. So it will become the size of A by 36. Because everybody is 1 over 36. So that's how the probability looks like, right? So the probability. So we mark this in purple perhaps, so that it's clear to us that this is a side discussion of the equal likely outcome experiment. What happened? Oh, sorry. Sorry about that. So it's an equal likely outcome, equally likely problem. That's what it's going to be. So now all I have to identify is, for the answer to this question is, what does x equal to 7 look like in S? Right? So you look at the event x equal to 7, right? How does it look like? This is when the dice sum is 7, right? That's what it is. That means one has to be, you can start with a 1 on the first row. I mean, second has to be a 6. That's a fixed, no question about it, because sum is 7. The second is, first is a 5, 2, second has to be a 5. First is a 3, second has to be a 4. The next is a 4, the next has to be a 3. And if it's a 5, it has to be a 2. And let me just move across. So this is a little bit easier. May I use this? So 2, 5, and if the first is 6, the next has to be a 1. So these are all the possibilities that give you x equal to 7. Right? There's no other possibility. And this is your set A, right? In the sample space. So the probability of x equal to 7 is the same as the probability of A. But that we know is the size of A by 36, right? So here 36 I put 36. Size of A by 36. But what is size of A? 1, 2, 3, 4, 5, 6. So it is 6 by 36. That's the answer. That's 1 by 6. Is that clear? Friends. So that's answer for 8A. So let me just make it a little smaller so you all understand it. So more than the answer 1 by 6, you should understand the setup. So the setup has two important properties. One is S is an equal likely outcome experiment. The second is the random variable X takes S to a range T, where T is 2, 3, 4, 5 up to 12. And the chance that X equal to 7 is just an event in the sample space. And the sample space event is considered 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. The number of elements is 6, so 6 by 36 is 1 over 6. Very nice. So let me now pose. So this is how you think about the experiment. So every element, random variable, whatever range it takes, you convert it to an element in sample space and do the problem. So now let me pose the last parts of question number 8 again. So all of you can try it. Let me see if I can get it across. I think I have the image properly. Question 8, part 2. Very nice. Let me put this. Move across here. Make it bigger. All of you can see it. Very nice. Very good. So why don't we do question number 8, B, C, and E? So I'll give you 5 minutes, maybe 4:40, maybe till 4:50. You can all try 8, B, C, D, and E. And I would like you to do it the same way that I did question number part A. Okay. So let me leave that also as it is, so you can see part A, how I did part A. So let me make it a little smaller, so you can see the question and show the answer here for the part A, how I did it. Okay, very good. So how are we with the solutions? Let's see. So there are 8 chats on that. 8 is this, B is this. Okay, yeah, that's right. Very good. So the idea is that not to get the answer. Very nice. So someone has tried to write down the combination. Very good. So probability y equal to 4. Very nice. So let's try and see how I would do it. Here's my pen gone. The pen is here. So again, if you're on chat, please. If you're on Zoom, YouTube, you can join the live link with this Zoom session if you like. I'm solving the assignment 3 questions as someone asked on the discussion forum. So let me go to question number 4, question number 8. So 8 again, 8b is y equal to 4. What is y? Y was value of the first guy. Right? So again, the question is the following. So now what is y doing? Let's do b first. So y is again takes the sample space to a range, let's say u, and what's going to u going to be? U is going to be the value of the first die. So u can be 1, 2, 3, 4, 5, and 6. Very nice. Well, that's what u is going to be. What is the question asking you? What's the probability? Y is equal to 4. So y equal to 4 means one value of u, but the inverse image is going to be what? It means the first, second, I'm not sure. Y is not a first guy. So first guy has to be 4. That means the probability of the set of the event, the first guy is a 4. It means the second guy can be a 1, the second guy can be a 2, second guy can be a 3, second guy can be a 4, 5, and a 6. Very good. Okay. So how many are there now? That means there are 1, 2, 3, 4, 5, 6. 6 of them. So again, size is 6 divided by 36, and the answer is 1 over 6. Very nice. Now, if you get it, some of you got it. Very nice. So let me do C now. C is the same way. C is a little bit complicated. Let's do probability x equal to 7, y equal to 4. Maybe I'll skip C. I can do x equal to 7. So probability x equal to 7, y equal to 4. I'm fixing both. So here the trick is I'm fixing both the range of x and y, right? So I'm fixing, what's going on? So probability of x equal to 7 and y equal to 4. That means the sum is 7 and the first roll is 4. That means the first roll is 4 means I look at 4. Next has to be 3 because sum is 7. That's it. There's nothing else involved. There's no other thing that will give me this combination. So it's a 1 over 36. Very nice. What is D now? D is probability x equal to 5. D is probability x equal to 5. What does x equal to 5 means? X equal to 5 means the sum is 5. It means the probability of the event is either 1 and 4 or 2 and 3, right? Or 3 and 2 and 4 and 1. You can't have any other outcome because if you have 5, that means already you have gone over 5. If you add one more to it, it will be 6. So this is again going to be 1, 2, 3, 4. This is 4 over 36. Very nice. This is 1 over 9. What about E now? What does E say? E says probability x equal to 5 and y equal to 4. So probability, let me do probability of x equal to 5. The sum is 5 and the first roll is 4. That means the only possibility is 4 comma 1. There's no other possibility. And that is 1 over 36. Very good. That's E. What is F asking? Is it true that x and y are independent? So independence is a very crucial concept in probability. I don't know how many of you have sort of thought about it. What does independence mean? Independence means that the outcome of random variable y doesn't affect the outcome of random variable x, and vice versa. So how does one judge independence? Independence one judges by, let me just give you a small, brief sort of digression to independence. So independence is a very crucial concept in probability. So independence means x doesn't affect the outcome of y, and y doesn't affect the outcome of x. That means the probability that x equal to 5 given y equal to 4 should be the same as probability x equal to 5. Okay. That's what independence would mean. Independence would imply. It means the occurrence, or the other way around, or the occurrence, I don't know if you thought about this, or the occurrence of x equal to 5, or sorry, the other way around, of y equal to 4 given x equal to 5 has to be equal to probability of y equal to 4. Okay. That means not only for 5 and 4, but in general, this is true. You would require, let me write it in green, the chance that x is in A given y is in B should be the same as chance of x in A whenever probability of y in B is positive, and vice versa. And the probability of y in A, y in B given x in A should be the same as y in B. This is whenever probability of x in A is positive. So both these conditions should hold. This is what independence actually means, okay, of two random variables. But what in discrete random variables, what you luck out with the following. This is something that I have hinted in the videos also, and you can look at my book. For discrete random variables, right? You can get away with independence. You can by the following idea. You can say x and y are independent you don't have to check all these for every event A, you don't have to check this, for every event B, you don't have to check this. All you have to check is you look at the chance that x is equal to s and y equal to t. Okay? And this should be the product of x equal to s times the probability of y equal to t. And this is true for all s in the range of x and all t in the range of y. Very good. That means these two probabilities multiply out, and when the multiplication happens, they should be the same as the joint probability of x and y. This is what gives you independence. So independence means it should be true for everybody. So what's the question asking you? The question asking you, is it true x and y independent? But what have we noticed? You look probability y equal to 4 here. Let's call this as plus sign. That's 1 over 6. Probability x equal to 5 here is 4 over 36. There's plus sign. Then the joint probability of x in 5 and 4 is 1 over 36. This is 3 plus sign. So you look at plus, 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 and 3 plus, you notice that the 3 plus probability is not equal to the probability of this times the probability of this. So what do? We notice now in our calculation, we note in 8F, for 8F, probability of x equal to 5 and y equal to 4 came out to be 4 over 36. And this person is not equal to, what is the multiplication of the other two? 1 over 36. Sorry, this is 1 over 36. Sorry, this is 1 over 36. It's 1 over 36. And this is not equal to 4 over 36, which was the, is 436, what is this? 4 over 36 times 1 over 6. So 4 over 36 times 1 over 6 times 1 over 6, which is the probability of x equal to 5 times probability of y equal to 4. That means they're not independent. So the idea clear. So then if you check, even if it's true, not true for one particular set of outcome, that means x and y are not independent. Is the idea clear? Is independence clear to everybody? Can someone just independence is very subtle, so it's an important concept. Right. So mutual exclusiveness and independence are not the same thing. They're very different concepts altogether. Very good. So anybody has any other question on independence? That for discrete unknown variable, this is all you have to check. You have to check probability of x equal to s and y equal to t multiplies out. And here in this example, it's not going to be true because this particular 5 and 4 is 1 over 36. But if you multiply those probabilities, you get something else. So they're independent. So let me now pose a question for you, which is their homework assignment 4. But we can try and see if we can do it in this conditional probability way. It's a very important concept in probability. Let me try and share it with you, see if you understand. So I'll write the question out a little different way. So you can sort of, it's like assignment, it's an assignment 4, but the concept is a little bit deep. So I'd like to sort of spend some time on it. So next half an hour, we'll try and do this. So here, again, it's not a question of dependence. Suppose an independent. Let's do a different question. Let's say x is Poisson lambda. That means it's a Poisson random variable with parameter lambda. Let me make Poisson 1, let's say, Poisson 10. Let's say. Then what I do is and let's say this represents like in the book, like in the assignment, the number of earthquakes in the region. And suppose let y be the number of earthquakes with magnitude above 5. Above 5, okay. On the Richter scale. Sorry, on the Richter scale. And what are we given? We're given each earthquake has, let's say, a probability 1/3, has probability 1/3 probability of being larger than, being magnitude larger than 5. That's the question. Okay. So this is the problem. So what I want you to do is, I want you to find the probability. I'll give you 5 minutes to answer. The question is, find the probability that y is equal to, let's say, 11. That is, there are 11 earthquakes in a year with magnitude at least 5. So the question clear on chat? Can someone, is the question clear to all of you? So you have your Poisson, X number of earthquakes is Poisson 10. each earthquake is magnitude 5 with probability P, which is 1/3. And I want you to understand what's the probability of y equal to 11. So why don't you all try? I'll give you 5 minutes, 10 minutes, maybe 5, 10, I will start solving this question. So now you can think of whether x and y are dependent, not dependent, what's going on. Okay, let me start. Let me try and give you some ideas how to start this problem. So what's the first thing one has to do? One has to do is the following, that so you want to find probability y equal to 11. So before that, let's understand what x is doing. Okay. X is running by itself. So the number I'm not so sure how to interpret. Let's try and see how to do the problem. So probability, let me erase this. So probability of x equal to, let's say, k. So x is Poisson. So x is Poisson 10. Means what? It's e to the minus 10, 10 to the power k by k factor. Right? This for k equal to 0, 1, 2, and so on. That's what x equal to 10. X equal to k. Now we also know that each earthquake is magnitude p, magnitude bigger than 5, with probability 1/3. That means, so let's say I want to understand what's the chance that y is equal to some number n given x is equal to some number k. So this one, immediately do the following. Suppose there are total k earthquakes, and if k is less than n, then this probability has to be 0. This probability has to be 0 if k is less than n. That's clear. And if k is bigger than n, so we want 11, right? So let's do 11. Let's do 11. 11 is here. So k is less than 11, this probability has to be 0, because if total number of earthquakes is less than 11, then you can't have 11 earthquakes above magnitude 5. That's not what I mean. That means your number of earthquakes is bigger than 11. So if k is bigger than or equal to 11, how do you do it? You have k total people, so you have k total earthquakes. Let's see, let me mark this in blue and this in red, perhaps. So you have k earthquakes. So let's say 1, 2, blah blah. You have k earthquakes. This is k earthquakes. Out of which you want 11 to be above 100, above 5. So you want to mark 11 of them among the k. So 11 of them are above 5. And the rest of them are below 5. Right? So that's like a binomial, right? So that's like binomial. That means it's just that you have to choose from the k. You choose 11 of them. Out of these 11 have to be bigger than 5. That means they occur with probability 1/3. So it's 1/3 to the probability of 11 of them. Right? That's 11. And the rest has to be below 5. That means 1 minus 1/3 to the probability of k minus 11. But that's what it's going to be. So y equal to 11 given x equal to k is going to be this problem. But what do we want to find? We want to find the probability of y equal to 11. So how do we do that? So probability of y equal to 11, how do we do that? So this is what we want to find. That's going to be equal to what? You look at 11 and x can be any k, and k can range from, okay, either you can put it from 0 to infinity, can be any k. And this is the probability, you can say same as the probability that y is equal to 11. Because this union is exactly y equal to 11. This is the sort of all possibilities by which y can be 11. But that's the same as if you use the countable axiom of probability, all these events are disjoint. So same as summation k equal to 0 to infinity, the probability of y equal to 11 and x equal to k. Right? Just by the axiom 2 of probability. Right? Axiom 2. Right, that's clear so far? That's all I'm doing. But now I know that this is the same as the sum from k equal to 0 to infinity. I do probability of A and B is same as probability A given B times probability of A. So I do it like probability of y equal to 11 given x equal to k times probability of x equal to k. This anyway I know is the same as is going to be 0 to 11. So by the previous definition, so summation k equal to 11 to infinity. This probability of y 11 y is 11 choose k, 11 choose k. So k choose 11. Sorry about that. It's k choose 11, and this is going to be 1/3 to the power 11, and 2/3 to the power k minus 11, and this is going to be e to the minus 10, 10 to the k by k factor. That's what the probability is going to be. Very good. That's easy. But now, how do you evaluate this sum? So let me mark this in green. So this green part is here. The green part is here. Sorry about that. Here. So all you have to do is you get it out. You put e to the minus 10. That's outside. That's constant. That doesn't depend on k. Right? And also here, 1/3 to the 11 doesn't depend on k. So you can bring it out. So it's 1/3 to 11 doesn't depend on k. It comes out. And what I have is the sum. You get the sum in black. The sum from k equal to 11 to infinity. I have k choose 11. So I write that as k factorial, 11 factorial, k minus 11 factorial, right? And this is already gone outside. So I have 2/3 to the power k minus 11. That I remember. And this e to the minus 10 has gone outside. K factorial is there. So I have 10 to the k by k factorial. So the two k factorials cancel. Right? This k cancel with this. So all I'm left with is e to the minus 10, 1/3 to the power 11. And this guy is going to be sum from k equal to 11 to infinity. And what do I have here? I have 11 factor also comes out. So I leave 11 factor also comes out. So put 11 factor also out. And what I have here, I have 1 over k minus 11 factorial. I have 10 to the k. And this 2/3 to the k minus 11, I'll leave it like this, 2/3 k. This is what I have. Very good. So now what I do is I do a little trick, a small trick, because everybody is k minus 11 here. K minus 11, k minus 11. There's only k here. So I just do a k minus 11, then I have to multiply by 10 to the 11. So I leave 10 to the 11 outside. Okay. I do a small trick now. That's all. And now what happens? If you identify this guy, this whole person right here, let me do it in pink, this whole person right here, this whole people right here is going to be what? I can rewrite this as the sum from k equal to 0 to infinity, 10 power, or let's say I'll write as m equal to 0 to infinity, 10 power m by m factorial and 2/3 power m. And this I can again think of this as these two together. So that's the same as the sum from m equal to 0 to infinity, 10 into 2, that's 20 by 3, right? 20 by 3, 20 by 3 to the power m by m factorial. And here what I'll do on this side, I'll just keep it like this. This is e to the minus 10. I'll leave it like this. This is 1/3 and 10. That is 10 by 3. So 11 factorial at the bottom. And this is 10 by 3 to the power 11. So I'll leave it like this. This is e to the minus 10 by 11 factorial, 10 by 3 to the power 11. But what is this guy, this pink guy, if you stare a little bit, that's just the power series for e, right? Because e to the x is just summation x power m by m factorial. So this person is a fact in analysis. This is just going to be e to the 20 by 3. That's just a fact from calculus. That exactly that. Let's do the mark in purple. Sorry. So this outside is e to the minus 10. Sorry, e to the minus 10. by 3 to the power 11, whole thing by 11. So we you should get so you'll get e to the 10 times this is minus 10 3. This is 10 by 3 to the power 11. Just it involves a lot of conditional probability as well, right? So let me draw this line here. So I had X is Poisson 10. Number of earthquakes in the region is my screen is gone. So there's this, and then I asked you to find the number of what's the probability that y is equal to 11. Right? So the calculation for y equal to 11 is a little bit tricky. It's a little bit subtle, right? So because the idea is that you only know conditional information. You only know this part of the problem. You only know this part, right? This is all you know. From this star, you have to understand the problem. That is, you know that the number of earthquakes is Poisson, but each of them being above 5 is probability 1 prime. So that means if you have probability y equal to 11, given x equal to k, that's going to be 0 if k is less than 11. And there'll be a binomial if k is bigger than equal to 11. Because you think of a success as having an earthquake with probability bigger than equal to 5. And a failure if it's less than. So it's a binomial experiment with 11 successes. Very nice. So then the next thing to do is you have to understand how to compute probability y equal to 11. So that you first understand probability y equal to 11 is the same as probability of y equal to 11 and x can be anything, k. And that by the axiom 2 of probability gives you sum from k equal to infinity of probability y equal to 11 and x equal to k. This also you don't know how to do it yet. But this you write down as probability y equal to 11, condition x equal to k times probability x equal to k. And these two things you know from start. This is from start. And once you do that, you're on your way. All you have to do is do a little jugglery with this k and 11 a little bit, get to this particular number, and get this and find the answer. Very nice.